All right, this is lesson 9.2, angles of parallel lines cut by a transversal. So just like 9.1, this is a review lesson. This stuff should look familiar. You should have seen this in another math class before this. If not, that's why we're going over it now. We have two parallel lines. So first vocab word, parallel, you should know what that means. These two lines, lines M and N, I'll color them, let's say in yellow. Line M and line N are parallel. They run parallel to each other. They don't cross at all. If they were on a coordinate plane, they would have the same slope. Another word you should know, here I'll underline parallel. M and N are parallel lines. You should also know what a transversal is. A transversal is line L here. It's a third line that crosses the two parallel lines. When you have two parallel lines and a transversal, we end up with a bunch of different angles. I numbered them. We have 8 different angles here in this picture. And if you pick any two angles, they probably have a specific angle relationship that I've listed here. So corresponding angles mean they're in the same corner. Let's start with that one. So, for example, line M and the transversal L, they have an intersection, and angle 1 is in the upper left corner of that intersection. If we look at the other intersection, like where line L and N cross, angle 5 is in that same upper left corner. So 1 and 5 are what we call corresponding angles. They're in the same corner. Pause the video if you need to, but I'd like you to fill in other pairs of corresponding angles. Come up with as many as you can, and then come back and check your work. Hopefully, you found 3 pairs of angles. Angle 2 and 6 are corresponding because they're both in the upper right corner of their respective intersections. Same with 3 and 7 are corresponding, and 4 and 8 are corresponding angles. All right, the next angle relationship is alternate interior angles. And again, I wrote these little blurbs here just to kind of explain what those names mean. For most of these, the name is kind of self-explanatory. You just need to know what the words alternate or same side mean, and then interior versus exterior. So alternate interior angles means they're on alternate sides of the transversal. So angles 3 and 6, yep, they're on opposite sides of that pink line, so they're alternate. They're also interior because they are inside the parallel lines. 3 and 6 are definitely between the parallel lines. So angles 3 and 6 are alternate interior angles. Again, pause the video. Can you think of any other 2 angles that would be considered alternate interior? If you guessed angle 4 and angle 5, then you are correct. Those are also alternate interior angles. Next, we have same side interior angles. Sometimes they're called consecutive angles. These are angles that are on the same side of the pink line, and they're interior to the parallel lines. So the example we have is angle 3 and angle 5. They're consecutive because I can just trace all the angles at once. Like there's angle 3, and right next to that is angle 5. They're both same side interior or consecutive. Can you guess the other pair of consecutive angles? If you guessed angles 4 and 6, those are the other same side interior or consecutive angles. Next, we have alternate interior angles. They're on alternate sides of the pink transversal, and they are exterior to the parallel lines. They're outside of the parallel lines, not in between them. So angle 1 and angle 8 are alternate exterior angles. Can you guess the other one? If you guessed angle 2 and angle 7, you are correct. Finally, we have vertical angles. We talked about vertical angles in 9.1. Vertical angles are anytime you have 2 lines that cross, they're the angles across from each other. So angle 1 and angle 4 are across from each other in this intersection? Can you come up with any other vertical angles? You should have seen 3 other pairs of vertical angles. Angle 3 and 2 are vertical angles. Angles 6 and 7 are vertical angles. And angles 5 and 8 are vertical angles. All right. So all of the above angle relationships are either congruent, which means they have the same measure. We use the equal sign with a squiggle above it. That means congruent. Or they are supplementary, which means they add up to 180 degrees. So if you take a look at this picture up here again, the ones that are congruent, like, I hope you all would agree with me that angle 1 looks like an obtuse angle in this picture. What are the other ones that look obtuse? Well, we know vertical angles are congruent from last chapter, so 1 and 4 are congruent. But 5 and 8 also look obtuse. They look congruent to 1 and 4. And that's exactly what ends up happening. Angles, I don't know, I'll use yellow. All of these angles, 1, 4, 5, and 8, are going to end up being congruent. And if I use a different color, maybe, I don't know, blue, 2, 3, 6, and 7, those are all congruent as well. And what will end up happening is if you pick any 2 pairs of angles and they're the same color, if you pick 2 yellow angles, they're congruent. If you pick 2 blue angles, they're congruent. Or if you happen to pick a yellow angle and a blue angle, those 2 angles would be supplementary. So let's go ahead and just take a moment to label each of these angle relationships with either congruent or supplementary. Let's look at these corresponding angles, like angle 1 and 5. Those are both yellow. They're both obtuse angles in this picture. Corresponding angles will always be congruent. Anytime you have 2 parallel lines in a transversal, corresponding angles will be congruent. How about alternate interior angles, like angles 3 and 6? 3 and 6 are both blue. They are congruent. How about same-side interior angles, consecutive angles? Well, 4 and 6 are same-side interior, or 3 and 5 are same-side interior. One's blue and one's yellow when I use my highlighter. Those are what we call supplementary. They add up to 180 degrees, or their measures add up to 180 degrees. What about alternate exterior angles, like angle 1 and angle 8? They're both yellow. They are congruent. And vertical angles, we know from last chapter, those are congruent. All right. You don't need to fill this in. It should say, if you did fill in the blank, it'd be complementary. But we talked about complementary angles last lesson, and it doesn't really apply to this picture. You might see 2 pairs of parallel lines. You can still think of this as M and N are parallel and T could be a transversal, or S could be a transversal to M and N. You could also think of this as S and T are 2 parallel lines, and you could consider N to be the transversal or M to be the transversal. So again, when you see anything like this, you can still highlight those angles that are congruent. There we go. So I'd like you to try these on your own. For these practice problems, you can look at the picture above here. Our angles 9 and 11, well, actually, name the relationship and then tell me if they're congruent or supplementary. Pause the video, try 1 through 4, and then come back and check your work. All right, angles 9 and 11 are both in the upper left-hand corner of their respective intersections. They're corresponding angles, and they're congruent. Angles 4 and 15, well, we would consider these 2 parallel lines, M and N, and T would be the transversal. So these are what we call alternate exterior angles. They are congruent. Angles 6 and 7. Those, one's yellow, one's blue. And we can think of S and T as the two parallel lines with M being the transversal. These are consecutive or same side interior. And those are the ones that are supplementary. Finally, angle 12 and angle 15, they're vertical angles, so they're congruent. All right. On the next page, we have example 1. And if you notice, we have two lines that are crossing, so these are vertical angles. The trick is now we have an equation that we can set up. We know this angle has to have the same measure as this angle, but they give us an expression for the angle measure. So what we can do is say, well, if 5x is the measure of the angle on the left, and 2x plus 24 is the measure of the angle on the right, and they have to have the same measure, well, then those measures need to be equal. So 5x is going to equal 2x plus 24, because we have vertical angles. And we've solved lots of equations like this ever since the beginning of last semester. We can subtract 2x from both sides. We would get 3x equals 24. And if I divide both sides of this equation, 3x equals 24, by 3, I'd be left with x on the left side and 8 on the right side. And we just solved for x. Let's try example number 2. We have really 3 different angles here. I'm hoping you can see angle ABD, as well as angle DBC, and then the big angle ABC. So we're going to use something that's called the angle addition postulate. It's a big word, but all it means is that if I take this blue angle and add it to this green angle, it will have the same measure as this red angle. So 2x plus 10 is the blue angle. If I add that to 4x minus 3, really I probably should, it's a good habit to put these in parentheses at first, even if they end up not mattering later. It should equal, the problem is telling me that the measure of angle ABC is 145 degrees. So again, I can solve this for x. I could start by combining my like terms. 2x plus 4x is 6x. And I've got a 10, but I need to subtract 3. So 10 minus 3 is 7. It's still going to equal 145. If I subtract 7 from both sides, I'll just have 6x on the left side of the equal side. And 145 minus 7 should give me 138. If I divide both sides by 6, I'll have x equals 23. All right. Try example 3 on your own. There is one trick that I'll show you to help you get started. We actually were given this angle up here. Its measure is 2b minus 15. And this red angle here is 3b plus 25. I did not give you a name for this kind of an angle. They are same side because they're on the same side of the transversal, but compared to the parallel lines, they're exterior. They're outside of these parallel lines, not in between. So we could call this same side exterior, but that's not in our table. That's just kind of a bonus. What you can do instead is you can use the fact that this blue angle is corresponding to this blue angle. And Corresponding angles are congruent, so we know that 2b minus 15 is the measure of this angle as well. That's the only hint I have for you. Pause the video, try to solve this on your own, solve for b. Okay. So I'm hoping, there are other ways you could have done this, but if you use my hint, then these two angles form a straight angle, form 180 degrees. They're supplementary. So 2b minus 15 plus 3b plus 25 equals 180. Combine your like terms, and you should get 5b plus 10 on the left side of the equal sign still equals 180 on the right. Solve that, and you should get b equals 34. All right, and that's all I have for you for lesson 9.2. There's a summary here. So what you can do is fill in this table just to list the angle relationships. So you might write vertical angles are congruent. Well, you write it in. Vertical angles are congruent. As a bonus, you can either ask a question at the end of the video, or you can answer this question instead. Where would we put that extra, the same side interior? Would same side interior angles go in the congruent side or in the supplementary side? Or if you don't want to do that, ask your own question, make up your own question, and I will see you all in the next video.